Okay, moving on to question 2, 2a. So they want us to estimate the square of 3 to 1 decimal places. The first thing we want to do is, be able to identify that the square root of 3 is just in between the square root of 1 and the square root of 4. So that's 1, that's 2. The square root of 3 is right here. So we can say that from 1 to 4, the entire distance is 3. And from 1 to 3, from square root of 1 to square root of 3, if you just look at the number inside the square root, the distance is 2. So now I can say that the square root of 3 is approximately equals to this squiggly equal sign means approximately equals to. So it equals to 1 because it's in between 1 and 2. So 1. And then the fractional part is going to be 2 because from 1, the square of 1 to square of 3, the distance in between them is 2 over 3. So this 3 from square of 1 to square of 4 is. So this equals to 1.7. So you can get that by just doing long division. If you just do 2 divided by 3, you should get 3 goes into 2 0 times, add a 0.0, line up the decimal points. 3 times 6 is 18. And then we subtract them to get a 2, move down the next 0, add a 0, move down the next 0, and then we'll get 6 again. So 0.66, if you round it to 1 decimal places, you get 1.7. So the answer is 1.7. Okay. And they asked us to check with a calculator, so I just need to type in the square root of 3 to see if my answer is correct. So here's my calculator. The square root button is right here. Square root of 3 equals. They give me a radical answer. To change it to decimal, we press this button S to D. So it gives us 1.73. So our answer is correct, 1.7. When we round to 1 decimal places. Okay, and then B, square root of 5. Same idea. I have square root of 4 and the square root of 9. This is 2, this is 3. The square root of 5 is in between them. From square root of 4 to square root of 5, the distance is 1. From the square root of 4 to the square root of 9, the distance is 5. So we can say that the square root of 5 is roughly equals to 2 and 1/5. And 1/5, if you change that to decimal, it will just be 0.2. So the answer is 2.2. And I check with my calculator, the square root of 5 is 2.2, is correct. Question C. Square root of 8. So square root of 8 is in between square root of 4 and the square root of 9. This is 2, this is 3. The square root of 8 is right here. From 4 to 8, the distance is 4. From 4 to 9, the distance is 5. Or you can say square root of 8 is roughly equals to 2 and 4/5. And if we change 4/5 into decimal, we should get 0.8. So the answer is 0.8. When I'm done, I check with my calculator. And it's correct. D, square root of 10. Square root of 9 and the square root of 16. Square root of 10 is right here. This is 3 and this is 4. So from 9 to 10, the distance is 1. From 9 to 16, the distance is 7. So square root of 10 is roughly equals to 3 and 1/7. So 7 goes into 1 0 times, 7 goes into 10 one time. And then 7 goes into 30 4 times. So we can say this equals to 3.1. And again, we check with the calculator. The square root of 10 is 3.2, actually, if you round it to 2 decimal places. So the correct answer is actually 3.2 here. So it happens sometimes our estimation is not 100% perfect, but I would say 80% of the time we are correct using this approximation method. Okay, so that's why the test will ask us to check with a calculator. Okay, and then E, square root of 20. Square root of 16 is 4. Square root of 25 is 5. The square root of 20. So from 16 to 20, the distance is 4. From 16 to 25, the distance is 9. So the square of 20 roughly equals to 4 and 4 over 9. This equals to 4.4. If you divide 4 over 9, you will get 0.4. And now I've checked with my calculator and I get 4.5. So again, we're off just by a little bit. F, square root of 30. Square root of 25 is 5. The square root of 36 is 6. Square root of 30 is right here. So from 5 to 30, the distance is 5. 25 to 30. From 25 to 36, the distance is 11. So we can say square root of 30 is roughly equals to 5 and 5 over 11. If I do a long division, I get 0.45 for 5 divided by 11. So if we round it to 1 decimal places, it will be 0.5. So this is 5.5. And once again, we check with a calculator. And 5.5 is correct. G, square root of 40. So square root of 36 is 6. And the square root of 49 is 7. Square root of 40 is in between them. From 36 to 40, the distance is 4. From 36 to 49, the distance is 13. So square root of 40 is roughly equals to 6 and 4 over 13. 4 divided by 13, add up 0.0, line up the decimal point. 13 times 3 is 39. And 13 goes into 10 0 times. So this will be 6.3. And again, we check with the calculator. And 6.3 is correct. H, square root of 60. Square root of 49 is 7. Square root of 64 is 8. Square root of 60 is in between them. From 49 to 60, the distance is 11. From 49 to 64, the distance is... I can just subtract them, I get 15. So square root of 60 is roughly equals to 7 and 11 over 15. Now I divide them. 15 times 6 is 90. Actually 7 is 105. Subtract, add another 0, move it down. 15 goes into 53 times. So this will be 7.7. And again, I check my calculator, check with my calculator, and I also get 7.7. I, square root of 90. Square root of 81 is 9. Square root of 100 is 10. Square root of 90 is right here. From 81 to 90, the distance is 9. From 81 to 100, the distance is 19. So we can say that the square root of 90 is roughly equals to 9 and 9 over 19. And now we can just divide them. 9 divided by 19. And a 0.0, line up the decimal point. 19 times 5. Or no, not 5. 19 times 4. That's 36. 76. So subtract 10 minus 4. 6 is 4. 8 minus 7 is 1. Add a 0, move it down. So maybe 7. 63. And 13. 7 plus 6 is 13, yeah. And then we subtract. And that's it. So rounding to 1 decimal places, it will just be 9.5. Square root of 90. Yeah, 9.5 is correct. J, square root of 150. The square root of 144 is 12. And the square root of 169 is 13. And 150 is in between them. 144 to 150, the distance is 6. 144 to 169, the distance is 25. So square root of 150 approximately equals to 12 and 6 over 25. 6 divided by 25 and a 0.0. 2 times 25 is 50. Subtract. And then 25 times 4 is 100. So 12.2. When rounding to 1 decimal places. And then again, we check with the calculator. And it's correct. 12.2 is correct. Okay. Square root of 200. Square root of 196 is 14. The square root of 225 is 15. Here is square root of 200. From 196 to 200, the distance is 4. And from 196 to 225, the distance is 29. So we can say that the square of 200 is approximately equals to 14 and 4 over 29. 4 divided by 29 and a 0.0. 29 times 1 is 29. Subtract. And a 0. Does 4 work? Yeah, 4 is too big, so 3. 29 times 3. 9 times 3 is 27. 3 times 2 is 6, plus 2 is 8. Okay, so this equals to 14.1, rounding to 1 decimal places. And again, we check with the calculator when we are finished. And 14.1 is correct. L, square root of 300. So square root of 225 is 15. And the square root of 256 is 16. So those are too small. So I should use 289 for 17 and 324 for 18. And then we have the square root of 300. So from 289 to 300, the distance is 11. From 289 to 324, the distance is 35. So we can say square root of 300 is approximately equals to 13 and 11 over 35. 11 divided by 35 is just 0.3. So 17.3. And when we are finished, we check with the calculator the square root of 300. Square root of 300, we get 13.3. I mean 17.3. Okay, that's it for question 2. I'll see you in question 3.